thing which I didn't tell you in reflection topic, which is the concept of principle of least time. What does principle of least time say? Principle of least time says that light takes the path from one point to another whether it be reflection or refraction, such that it takes the least time. So what does principle of least time say? It says that light will only take the path from one point to another such that the time taken by it is minimum. So I'll use this principle of least time to prove the Snell's law. You can also try this on your own. So if you are very curious, then you can try this, or else just have a look on the proof. So let's say that this is my incident ray, this is normal, and this is my refracted ray. This angle is I, this angle is R. Okay, let's say this medium is mu A and this medium is mu B. Let's assume that this height is h of A and this height is h of B. Let's assume that this width from here, this point to this point is W. Okay, now what is W in terms of HA, HP, I and R? I can write it as HA tan of I plus HB tan of R, right? Okay, now what is the time taken by this light to reach from this point to this point, from this point to this point? Let's say this time is t. It is equal to this distance divided by the velocity in this medium plus this distance divided by velocity in this medium. So what is this distance? This distance is nothing but HA sec I. So I need to divide with by the velocity in this medium. Let's say the velocity in this medium is v1. So I write v1 plus this distance is HP sec I sec R. Just divide by, let's say the velocity here is v2. So divide by v2. Now let's multiply this with c. Okay, so Ct is equal to, what is c by v1? C by v1 is equal to the absolute refractive index of this medium, as we had discussed. So this is equal to mu A HA sec I plus mu B HP sec R. Okay, now let's differentiate this equation and this equation. Let's say this is equation 1 and this is equation 2. Let's differentiate both. When we differentiate the first equation, what we'll get? 0 is equal to, we'll differentiate with respect to angle of incidence I. HA mu A, sorry, I'm differentiating the first equation, right? So HA sec square I plus HB sec square R dr by di. Now when I differentiate the second equation, C dt by di. Now if this follows the principle of least time, that means the time taken is minimum. If the time taken is minimum, that means what? dt by di is 0. This we had studied in maxima minima chapter of calculus, that whenever some function is minimum or maximum, its differentiation is 0. So this quantity is 0, dt by di. So c into 0 is 0. So I'll write 0 is equal to HA mu A sec I. When I differentiate, I'll get sec I tan I plus mu B HB sec R tan R dr by di. Okay. Okay. Now if we simplify this, we can write this as mu A HA sec square I sin I. What I did was I wrote tan I as sin I by cos I, 1 by cos I is sec I, plus mu B HB sec square R sin R dr by di. Now you see HB sec square dr by di. HB sec square dr by di is what? Minus HA sec square I. So I can write mu A HA sec square I sin I plus mu B HP sec square I dr by di. I can write this as minus HA sec square I, and here I have sin R. Now you see that HA this gets cancelled. So I am left with, I can drop this, I guess, yes. So I get 0 is equal to mu A sin I minus mu B sin R, or I get sin I by sin R is equal to mu B by mu A, or I can write the sine of the angle of incidence, the ratio of the sine of angle of incidence divided by the sine of angle of refraction is equal to the relative refractive index of the second medium or the refractive medium with respect to the first medium. The second medium was B and the first medium was A. This is the relative refractive index, and hence my Snell's law, which is this, has been proved. Okay. Now using the principle of least time, you can also prove the mirrors formula, any law like the angle of incidence is equal to angle of reflection, the mirrors formula, which is 1 by u plus 1 by v is equal to 1 by f. Everything can be proved using principle of least time, because since these formulas are valid, it has to follow the principle of least time. Now let's take one case.